Hello everyone, my name is Han Shengxiang and this is question 1 of homework 6 in the course probability and stochastic process. And in this question, there is a density function of xy is equal to 1 plus the x times y over the a when the absolute x is smaller than 1 and absolute y is smaller than 1, and the x and y are jointly density. The question A is we want to find the A so that the function is a valid joint density function. So we could integral the density function, and the probability of 8 is equals to 1, and it is equals to the x from -1 to 1 and the y from -1 to 1, and the density function of xy is equal to 1 plus xy over a, the dx dy, and the xy over a is odd function, so the integral of 8 is equal to 0, so it is equal to the integral of -1 to 1 and -1 to 1 dx dy, and it is equal to a over 4 and is equals to 1, so the a is equal to 4, and the density function of xy is equals to 1 plus the xy over 4. The absolute x is smaller than 1 and absolute y is smaller than 1, and otherwise is equals to 0. And for question 2, we want to prove that the xy are uncorrelated or not, and to prove that, we want to compute the expected value. The expected value of x is equal to the integral of x times the fxy dx dy, and it is equals to x times the 1 plus xy over 4 dx dy, and it is the odd function, so the value of 8 is equals to 0, and the expected value of y is equals to integral of y times the density function of xy, and it is equals to this y times the 1 plus xy over 4 dx dy is also the odd function is equals to 0. And we want to compute the expected value of xy. It's equals to the integral of x times y times the density function of xy is equals to xy times 1 plus xy over 4 dx dy, and it is equal to the two parts of this is this part is and plus this part, and we will compute the two part of the integral, and the first part is equals to the -1 to 1, and this is the for so this part is equals to 0, and plus this part and to compute this, it is equals to the y is equals to -1 to 1, and the -8 it is equals to 2 is to compute this is equals to 1/6 and times the y to the power of 2 to integral the -1 to 1 the dy, and it is equals to 1/6 times 1/3 the y to the power of 3 when the y is equals to -1 to 1, and it is equals to 2, and it is equals to 1/9, and the expected value of x times y is not equals to expected value of x and times the expected value of y. So the x and y are not uncorrelated because x, y are not uncorrelated. So for question 3, we want to prove that the x, y are independent or not. Because they are not uncorrelated, so they are also not independent. And for question 4, we want to compute the joint density function of x to the power of 2 and the y to the power of 2. And to compute that, we could set the z is equals to x to the power of 2, and the y is equals to the w is equals to y to the power of 2, and we want to compute the matrix of it. The joint cos matrix is equals to the dz over dx, and the dz over dy, and the dz over dw over dx, and the dw over dy, and it is equals to the 2 times x, and it is equals to 0, and this is 0, and it is equals to 2 times y, and it is this is equals to 4 times x times y, and because of z is equals to x to the power of 2 and w is equals to x y to the power of 2, and there are 4 roots. So when z is from 0 to 1 and w is from 0 to 1, and the gi is equals to 4 times the square root of z and the square root of w, and the I is equals to 1, 2, 3, 4 roots. So the density function of zw is equals to the density function of xy when the x is the square root of z and the y is the square root of w over the absolute of g1 and plus the second root of g2 and the third root of g3 and plus the fourth root of g4. So we could compute it, and it is equals to the 1 over the 4 times the square root of the square root of omega or w, and times the 1 over 4 times the 1 the first part 1 plus this, and the second 1 minus, and plus the 1 minus, and plus the 1 plus, and it is this part is equals to 0. So it is equals to the 4 times the square root of the square root of omega. The numerator is equals to 1, and it is equals to 2 parts times together, and the first part is 1 over 2 times the square root of z, and times 1 over the 2 times the square root of omega w, and it is like and this is the zw density function, and when the z is from 0 to 1 and w from 0 to 1, and for otherwise it is the value is 0, and it is equals to 2 parts compute times together. So the fzw is equals to fz times fw is equals to this 2 part times together. So this part is fz and this part is fw. They are joint function of z and w. So the x to the power of 2 z, the y to the power of 2 w are independent, because the density function of zw is equals to density function of z times the density function of w.